So here is the problem statement. So in this numerical, what we have to do, the given case is presented in which there is a conference room, and in the conference room there are 100 people seated. So we have to find the apparatus dew point, the grand total heat load, and effective room sensible heat factor. So for this we will note down the given things. The number of persons which are available are 100 as per given in the data, which is to be maintained at 22-degree dry bulb and 60% relative humidity. So this is the required condition. So we have denoted it as zero point 0.2. So the dry bulb temperature is 22 degrees Celsius and the relative humidity is 60%. The outdoor conditions are 40-degree dry bulb temperature and 27% wet bulb temperature. So we have noted in the given section. Then the latent heat per person is sensible heat per person is 80 watt and the latent heat per person is 50 watt. So the latent heat also coming from different light and fans is 15,000 watts, which we can write as 15 kilowatt, and the latent heat which is coming through sensible heat which is coming through glass walls ceilings is 15 kilowatt. The air infiltration is 20 meter cube per minute and Vf is 100 meter cube per minute. The bypass factor is 0.1. So now we will look in the flow of the numerical, how the system is there. So in this, the point 1 represents the outside air condition. Then the air undergoes mixing. So after mixing, it passes through over a cooling coil and then it goes to the room. After the room, in the question it is mentioned that 2/3 of the air is recirculated and again came for mixing. So here is the flow of the numerical. So first what we'll do, we'll plot all the points on the psychrometric chart. So first we'll plot the conditions in which is given at 40-degree dry bulb temperature and 27-degree wet bulb temperature. So this is our point number 1. We are plotting. How we'll plot? We'll draw a line from 40-degree straight and 27-degree on the wet bulb line. So we'll get point number 1. Similarly, we'll also plot number 2 on this graph, which is on 22-degree dry bulb temperature and 50% relative humidity. So we have got this. Then we'll join the points. We'll join the point 1 and 2. As we all know that this is all the formation due to latent heat and sensible heat. So we have named point A. So it results due to 1A and 2A. Then after plotting this, what we'll do, we will find all the other properties which are required for us. So we are plotting now the specific volume of the air. How we'll plot it? We look at these lines at the bottom. So in the inclined way, this represents specific volume. So they tells us about a specific volume. So we are plotting it at point number 1. So at point number 1, the specific volume is 0.911 meter cube per kg of dry air. Similarly, we will be plotting and noting down the data for enthalpies at point 1, 2 and 3. How we will note down the point for enthalpy? It is very simple, as from point number 1 we will extend it inclined way and we can plot it. As we can show that on point number 1 it is somewhere around 85 to 90 in between. For point number 2 it will be around 45 to 50, and for point number A we will draw an inclined line and we will plot the enthalpies. So similarly we will get enthalpies for H1, which is at point number 1 the enthalpy is 85 kilojoule per kg. At point number 2 it is 47.5 kilojoule per kg of dry air, and for point number A it is 66 kg of dry air. Next, as it is mentioned in the question that mass infiltration is there, velocity of infiltration is given. So we'll find out the mass. How we will find out the mass? By using the formula, which is the velocity upon specific volume. So we will get the mass, which is 21.95 kg per minute. So we will now find out what is the sensible heat gain, as there are number of persons present in the room. So we'll be finding the sensible heat gain by the person and latent heat gain. So for finding the sensible heat gain, Due to infiltration, there is a formula which is the mass flow rate of the air multiplied by the enthalpies. So 21.95 is the mass flow rate and the difference between the enthalpies. This will give us the sensible heat gain due to infiltration of air. Similarly, now we have to find out the sensible heat gain from persons. So as given in the question, there are total 100 persons in the conference room and each person is having a sensible heat of 80 watt. So total sensible heat in the conference is of 8 watt, which is only coming from the person sitting there. Similarly, the latent heat from the person is also 50 per person multiplied by the total number of persons in the hall, which gives us 5 kilowatt. So we find out total sensible heat gain from person and total latent heat gain from the person. So now what we have to find, room sensible heat. So what are all the factors which are contributing to room sensible heat are, we will be adding up the sensible heat from the infiltration of the air, the sensible heat gain from the person, plus sensible heat gain due to lights, fans, plus sensible heat gain through glass, walls and ceilings. All the values which were mentioned in the given, we will be adding them in order to find out the room sensible heat. So we are getting the value of 44.77 kilowatt, which is the total room sensible heat. Now we will calculate the latent heat from the room. For calculating the latent heat, we does not consider glass heat gain from the glass or from the lights, but we consider the heat gain from infiltration and the heat which is given out by persons, the latent heat. So we'll be adding it and we'll be getting the room latent heat as 11.95 kilowatt. So for calculating RSHF, room sensible heat factor, there is a formula which is the room sensible heat upon room total heat. Total heat comprises of sensible heat plus latent heat. So we'll be adding all the values and substituting it, and we have obtained 0.79 as the room sensible heat factor. So this picture also portray that total heat, sensible heat and latent heat that will be taking place in case of conference. So now what we will do, as we have already plotted our triangle, the next step in our plotting is we have to plot the point of sensible heat factor on this. So it was around 0.79, so we have plotted it at 0.79. Then there is a reference point in this chart which helps us to, and we will be joining it. So as we join the line which is highlighted in the red, A to B, we have to take the same line parallel to line AB and draw it from point number 2. So as we draw it from point number 2, it will somewhere intersect the curve and will give us point number 5. So this line is the room sensible heat factor line. So RSHF line we will get from this. So for calculating the apparatus dew point temperature, what we have to do, we will be getting all the dew point temperatures of the various points. So which is as mentioned as in the question, two-thirds of the air will be recirculated, and we also know bypass factor was also given. So depending on that, we have to divide that line into parts and we will get the dew point temperature on various points. So we can here find out that by trial and error method we are getting the dew point temperature of 4 at 13.15 and at point number 6 at 11.5 degrees Celsius. So we'll be plotting them on the graph as point number 5 and 4. So we are getting this line, and then as we have got the point number 6 and 4, we will be drawing a line from point number 6 to point number 3. Point number 3, how we got, as in the question it is mentioned, so the mixing ratio was given and point 3 will be like to point number 2. Now we have to calculate the grand total heat. So grand total heat, we can consider that the outside total heat, which is in formula present, is 0.02 infiltration of the air multiplied by the enthalpies. So we are getting the outside air total heat as 15 kilowatt. Then we are also finding out the grand total heat. The grand total heat is the sum of room total room sensible heat plus room latent heat plus outside heat which is present. So addition of all of this will give us the grand total heat load, which is around 71.72 kilowatt. In the question that was also mentioned, we have to find out the effective room sensible factor. So for this we will again come to our psychometric chart, and we will be joining the point from 6 to 2. When we join the point from 6 to 2, the area is known as effective room sensible heat factor, and it is given as, from the graph we are plotted, it is 0.77. So in this numerical we have studied about how to calculate the heat load, cooling load on when there is infiltration, when there are number of people present in the conferences, on what are the things which are occupying the contributing to sensible load and latent heat load, and we have found out what is the effective room sensible factor. Thank you, sir.